Hello, my name is Mohamed. This is my AI research. I read the chapter by David Graham about breathing life into your background characters, uh, particularly NPCs, not like main characters or anything. The characters in your game that mostly work as backdrop that give the world life. All right, so why even have background characters that are, realistic? Well, the reason you have in the first place is to give, as I said, give the world life. It is a lot more immersive to have believable background characters, regardless of if your game is a shooter or a MOBA or any genre really that needs a world that should feel like it is lived in. It definitely helps to have believable characters outside of the ones that you immediately interact with. NPCs can also serve as a means of storytelling. You know, the old famous show don't tell. Instead of telling the player that something's happening, you can have background characters or NPCs react a certain way to as I said, show don't tell the player what is happening in the current situation, whether it's a threat, whether it's an event of some sort. So it's very useful to have background characters that act as the player would expect. All right, so to get into the technical side of it, background MCCs, as David points out, should be three things. They need to be efficient, they need to be scalable, and they need to be modular. Start with efficient. You cannot have so many NPCs at the same time running complex amounts of code every update because that takes a big hit on memory and processing power. So you have to have an efficient way to tell the NPCs what to do at any given time, and still make it look realistic. However, here, I don't know if any of you recognize this, but this is Assassin's Creed Unity. Ubisoft, I remember when this game came out, touted the idea of having very large and realistic crowds. Now, um, in the game, they pulled it off, but the thing is, with having so many different people, if you were to actually like run the game and you would see it, you can kind of see the cracks showing with having so many complex AIs. They kind of have to cut corners. You see a lot of familiar models, and giving Unity's technical state at the time, it just wasn't like it could have been done better. So it kind of just highlights the idea of having an efficient system in place that could handle that kind of thing. And on that note, you also have to have a scalable AI too, because when releasing a game, you have to consider the hardware that the player is using. So if a player can't handle a certain amount of AIs, you should be able to scale down the numbers of AI so that the processing can keep up. And also for development purposes too, if there's a certain area in the game during internal development that needs to be scaled down or scaled up, needs more or less NPCs, it should be easy to add and remove them. And it should be modular too. As programmers, we need to keep in mind that there are those like artists and designers who need to be able to use our systems by adding animations or art. So you should be able to make a system or a class structure as to where you can kind of have a skeleton like a template, and then they should be able to put their animations and art on top of it very quickly. All right. David mentioned several ways to go about it. A lot of them we are familiar with from the games that we play. Of course, you can, if you want to have some kind of simple behavior, you can just simply loop animations. Like over here, we have Andre the blacksmith from Dark Souls 3. He doesn't all he sits in one spot and he does one thing. This does give life, and it serves the purpose. It serves his character, but it's a little bit simple. You can have walk cycles. If any of you play Pokemon, I'm sure a lot of you have. You know that there are trainers in those games that kind of just walk from point A to point B to point C even, and just keep cycling. That's also a little bit simple. What David proposes in his chapter is the idea of a scheduler, which is like the main idea I'm going to be talking about. A scheduler is kind of like a black box, as he puts it, where the input is time and the output is action. Each object has a schedule that is tied to it via a pointer or ID, depending on how you want to go about it. Each schedule being attached to an object has a series or a collection, I should say, of schedule entries. Schedule entries, put simply, are chunks of time. So a schedule entry could have a start time and an end time. So like 0 to 5 seconds is an entry. And then each of those entries can have an action tied to it. So this action can be It's typically an animation, or it could be like some kind of trigger that an object can take. But with this structure, um, given a certain time, an object can ask its scheduler what entry pertains to that time, and then uh, grabs the corresponding action. Now, this is a very it's a simple approach, but it can be very powerful as it is the three things that was mentioned before. It can be efficient, scalable, and modular because it is data driven. So if you can have a database of actions and animations and whatnot, and you can pull them out of the collection at a given time. A scheduler, I believe, is more than just as you would know, a finite state machine, something that just reacts to the state and this changes because it takes time. You can make routines for certain characters. Like right now, I'm going to highlight the Minecraft villager, for example. So at a given time, as you can see in Minecraft time, uh, is input into the schedule and given an entry or a role, the villager's role or any particular threat, like if the village is getting raided or something, or their location, a certain action is chosen. And it's more than you can see. It's kind of more than dynamic state machine because there's so many possibilities that can go about it. No one villager does the same thing all the time because they're not. For one, if you look here, they might not always be in the same place. They might not be under threat. They're all different roles. So in a way, the scheduler, given its actions and this routine structure, they can all have this as kind of like, I guess you could have as say it like as like a default routine, and then you can have a bunch of other factors right here influence it as time goes on. Um, David put their code in their chapter, so I was able to look at how they would go about implementing it. And I noticed that for every time they want to find an entry, they have to iterate through every single schedule entry, which I mean is pretty inefficient. Imagine having to do this for like every NPC that is in a scene. Um, as the game gets bigger, these entries get bigger. You have to do this a lot, so there has to be a better way. And whenever I think about getting an entry at a certain time, like that kind of sounds like it's kind of begging to be a hash map. So I wrote an extra function in there. It assumes mTime buckets assumes that you have initialized kind of chunks of time. So you're kind of already because you set all of those entries in a database on the side because it's data driven. You can have each of those data entries be put into a time bucket at the very beginning, so you only have to iterate it through it once at the start. And then because it is a hash map, because it's a dictionary, you can just grab it, you can just find it, and it'll pass it back to you instantly, which definitely helps on the performance side of things. And also, sometimes your games might not always need to be influenced by time so much as as maybe other things. I've been playing Shadow of War recently, and I'm sure we all know about the Nemesis system. Now, it's a lot more complex than I'm going to make it sound, but when I think about it, it's really just instead of using time as an input, you're using certain player actions in the world. So if Talion, brutally kills an orc, or dies, or escapes, or is presented with some kind of victory, you can have each NPC given its role and given its location and given maybe its attack class or something, you can have it output a certain action. So an orc can celebrate or run or be alerted or anything in between. Really, it's really I think the main strength of the scheduler, as I've shown so far, is how robust it can be while also maintaining a data-driven structure that lets you just input like just put things into the database that you want it to be able to do. Of course, the Nemesis system is a lot more complex than this, but I imagine this is a very high level way that they thought about it when they were making it. Um, yeah. Rest in peace, Monolith. Are there any questions?